Yeah, thanks Fabian for the introduction. I'm Niels, also a rather impronounceable last name, so I'll skip that. I'm from AMLO, a small and upcoming startup from Zurich. Our slogan is making maintenance smart, but today I'm actually going to be talking about our procedural side of projects, mostly MLOps. This ties a little bit back into the old data-centric vision, but I also want to highlight why we see the need for MLOps. A bit closer. How we use it, how we implemented it, and about our tool set. But I'll start with a little introduction where I founded AMLO together with a uni friend about 2 years ago, and the first year was mostly with the mission to solve predictive maintenance. The first year was mostly consulting projects where we did a few predictive maintenance, but also some digitization in manufacturing projects, and we learned a ton. But we actually wanted to productionize, build a product out of these consulting projects. And so we went through this acceleration program of this incubator in Zurich. And last summer we actually launched a platform, our smart maintenance platform. End of last year we got some pre-seed funding and now are always looking for more pilots. And our smart maintenance platform is a no-code platform. To connect any type of industrial machine data and develop and manage operational machine learning without any programming or mathematics. So what we do is we pretty much take any sort of industrial data, whether that is comes from a blob storage, some SQL database, or anything. We combine that with a lot of information from ticketing systems, where a lot of the failure information is available. We combine this with live stream data that comes from IoT providers, and we all sort of merge this into one thing, where service engineers can develop this machine learning themselves. And that workflow is pretty straightforward. The service engineer has to connect the data that is generally already available, either over MQTT, HTTP, OPC. We support various imports. The service engineer, who's generally the expert in their machine data, is then doing the labeling as well. We do assist him in this process, but I'll tell a little bit more about that later. With one simple click, they can start our automated machine learning pipeline that turns this organized and labeled data set into a model. This is where the power of our framework comes in. This framework also has automatic serving, where we have in-house developed monitoring, API endpoint hosting, and everything integrated. And therefore we have a pretty clear separation of responsibilities. We have the service technicians that know a ton about their machines, that know all the little quirks in their data, but have generally not much experience with machine learning, coding, or mathematics. And then there's Team AMLO. We don't generally have much domain knowledge about the machines or the data that our platform handles, but we do have a lot of expertise in machine learning. And that naturally divides the tasks at hand as well, because we let our user organize and label the data, because that is what they understand. And then we provide the tools and the framework that turns this into valuable machine learning models. And that also ties in directly to the whole data-centric AI vision that I'm sure many of you have heard in the last couple of days, where the user is responsible for creating the initial data sets, training the models. We then tell him exactly at what points in the data sets there's potential weaknesses or potential improvements. And the user can iterate on this, maybe add some data here, maybe remove some data there, and retrain the models and do this very iteratively. Whereas the systems, our framework, is relatively static, right? Every time, if you would feed a training data set through the whole pipeline twice, the same result will come out. And to tell you a little bit about the business value and the use cases that we offer, I would like to talk you through our first customer story. This is also where the strong needs of machine learning operations for us came into play. And our first customer is Tritium, a manufacturer of electric vehicle fast chargers. They operate about 6,700 chargers worldwide. And these chargers are actually quite complex machines with a lot of power electronics inside them. And it takes a service engineer on average about 12 working hours to diagnose specific issues after a machine has failed. With our platform, they were able to develop automated diagnostics, which predicts approximately 80% of their failures, clearing up a significant amount of resources on their side, where they are able to reassign 80% of their service engineers. However, that was quite a lengthy process to get to. It took us about 9 months of slow iterations and unobserved issues to really get to a point where everything works robustly. And I think that many of these points are very stereotypical for this process, and also very strong arguments to having very solid machine learning operations. Firstly, we started off with too little data. This became obvious from various cases of incorrect predictions in production, but made us think, like, how can we create better training data sets? And so we enforced labeling, where every prediction would be labeled. Like, we would just spam the service technician until he clarifies what the actual incident was. But we also assist them with labeling on unsupervised data. Then in this case, they used some binary CAN data, which needed to be converted. And this was actually a piece of software from the customer. And a lot of conversion errors came through that software. And many of those sort of conversion errors would have been caught by data tests, but which we didn't really have in place at the beginning. Now, fortunately, we are able to catch them a lot easier. What is also very typical is that when we started this project, they mostly put European or data of European chargers in the training data. And then we started deploying these models, and we saw all these strange predictions for all those chargers in the US. Turns out they're operating on a completely different bus voltage, and the whole dynamics of all these power electronics is completely different. And this raised the strong need and desire for proper monitoring and inspection tools. And then lastly, and this also ties a little bit into that data conversion, they have various different modules, but the sensor naming, let's say, in the data, was the same without the module's name in front of it. So effectively, our models were interpreting voltage from, say, module A and module B as the same. And again, this raised the need for a deeper insight into the predictions, into the data that is actually used, and have prediction interpretability and accountability. And so that brings me to the focus for us on MLOps. It's pretty much two main drivers. Where first of all, we want to achieve a quicker model to market, which decreases our sales cycle, but also leads to quicker integration, adoption, and value gain, which is extremely valuable for our customers. So I really like the takeaway from Alexis and Moss as well. But for me, more importantly, is even the better ML machine learning models, because we have this faster iteration cycles and this deep insight into how the model works and what it takes in. You can improve on that a lot, and because the way from or the pipeline from training data to model and production is fixed. It's a framework. We've been able to robustify this framework and really make sure that there is no vulnerabilities in that process. And of course, that also ties back into continuous improvement. But what does that mean effectively? So we have a bit of a hectic workflow here, but that's because there's a lot happening in our framework. It all starts with data gathering, in which we believe that this is more the responsibility of our users, because data pipelines here are very customer or company specific, but that sort of enters our platform. Then with the labeling, we do help them a lot. Firstly, with expected labels of unsupervised methods, but we also recommend them which unlabeled sequences or time series data they should label, because that would give us the most value, let's say. We enforce the feedback and we identify label mistakes, which are also very common. well, then the whole model optimization and development is pretty much automized, as the data cleaning, feature experimenting, model and hyperparameter optimization is all a predefined search space. Here, from that output, we feed back those ambiguous labels to make sure that our users actually check those. The output of this model optimization is automatically deployed and comes naturally with data monitoring, performance monitoring. We analyze the main predictors for every prediction and host the API endpoints for our customers. From there, we also feed back into the data gathering to make sure that those data tests are actually passing. And obviously, all this information is fed back to the user, who plays then a vital role in making sure that we can iterate and improve on that. And I want to zoom in a little bit on the assisted labeling, because overcoming the time-consuming process of labeling and gathering data has been quite a challenge and is something that we see for many of our customers. And the idea here is that, what we do here is we exploit the ton of unlabeled data. The companies that we've been working with generally have a ton of Internet of Things data. It's just not labeled. And with our assisted labeling tool, we try to exploit that. So what we do is we cluster these sequences so that we can identify which sequences are likely to belong to the same class, so that as soon as a service engineer labels a first instance, we can provide him a very likely sample of the same class. But we also know exactly which clusters we don't have any labels of, and we would like to get some labels of. Furthermore, we can use these clusters to sort of identify what makes them unique, to present maybe the 5 more features that actually set those clusters apart, instead of the thousands and thousands of time series signals that are generally in these data sets. So effectively what we do here is focus the attention of our users to be as efficient in the labeling process as possible, by recommending which logs to label, by recommending which label it's likely is, but also by showing them only the signals that are relevant. And then the next step in the process is the automated machine learning package. This has been a work in progress for a while. But what we saw in many of our consulting projects is that many of the design steps of development of a machine learning model are very similar, where it's feature engineering, model selection, and hyperparameter optimization. So we have a predefined search space that is the same for every customer, but every model is optimized to the specific data set automatically. And because this is all automated and doesn't have any human in the loop, we're able to really create a robust framework with automated testing, built-in monitoring, interpretability analysis, and make sure that this process is the same every time. What is also very cool, I think, is the fact that we can super easily deploy this on spot instances in the cloud, so that a user can just start a training with one click, and the training is actually relatively cheap for our computational cost as well. I think that many people are often talking about this automated testing, but I feel there is often not much detail given about those tests, and so I wanted to dive a little bit deeper in there, because I think that this has been a very important part for us, and I think that we cover quite a lot of cases that are maybe generally not covered, such as minority sensitivity or invariance model tests. These all highlight performance issues very early on and allow for much faster iteration. Obviously, we also have like the proper software tests for all these frameworks. Then next is the automatic deployment. As I said before, like a user can start a training session or a model training session pipeline with one simple click. When that happens, we actually deploy an image to a spot instance with the training job in there that pulls all the data in, runs the pipeline. And once it's done, it just uploads the model back to the platform, destroys the virtual machine. And the API endpoints are automatically updated in case it's pushed to production, because they always check for the latest available version. So that makes the whole deployment super straightforward, and that also allows you to really with minimum effort be able to update your models and improve your performance. And then lastly, I would like to focus a little bit on the performance improvement, really the monitoring part of the systems in production. On the bottom right, you see an example of one of our customers, where you see two probability distributions. The orange being the training data set distribution, where you see a big spike around 0, and then an exponential distribution there, but no high values, whereas the data that we actually saw in production, you see a lot of values around 400s. And this is obviously a big problem, because this was actually quite an important feature for the model, and we were making all these predictions at values that we had never seen before, that the model hadn't learned about. And that decreases the performance of a model significantly, but it also very clearly identifies where your training data set is not so great and where you should probably add some data. And so this information is then fed directly back to the user, who can very easily identify, okay, 500 volts, that's probably those US chargers that we didn't include in the training data. Let me add some data from there. And so that all becomes very simplified for the end user in normal English terms. So we check for data drift, training production skewness, but we also check for ambiguous labels. We monitor our models when it comes to latency and RAM usage, and also do like prediction output analysis on that. And with that, I would like to conclude already. Did MLOps help us? Well, I started with our first customer journey, which took us 9 months. Last month, we onboarded a customer, and within the first week, we had 2 models deployed, and after a second week of testing, they were convinced of the POC, and we're now in talks for full deployment of the service. So that was a huge moment for us, because we pretty much went from 9 months to 2 weeks, which is ridiculous. The value and implementation was quickly and easily understood. Also we see it in the iteration speed, where our customers enjoy unlimited retraining, and you also see that they use this quite frequently, where it takes an average of 5 iterations before a model is truly sort of stable, let's say, and they keep iterating. And all of that while we have our customers enjoy all these machine learning methods without any coding or programming experience, and that all because of the clear separation in responsibilities, where the user is really responsible for this data gathering and labeling, and we are really responsible for providing the whole framework. And with that, I would like to close and open the room for some questions.
We can take maybe 1 or 2 questions, then we break for lunch.
So thanks a lot for the interesting talk and a very nice platform. Maybe one question I would like to understand like a bit your user base, because I mean you provide quite a techie tool for them, and you talk about concepts like outliers, like machine learning. I think in our world these are very understandable. I just want to understand if your customers sometimes say like, I have no idea what you're talking about, or would they feel more tech savvy when they're encountered with such a tool? What's the usual first reaction to this kind of tool?
Right. So we're dealing with various stakeholders generally within a company, where we see that the actual service engineers or technicians pick the concepts up relatively quickly, because frankly their demographic is just a lot younger. However, when we are dealing with the managers or the COOs, this tends to be a little bit different, where we have to take a little bit more time to go through certain machine learning concepts, because at the end of the day, we simplify sort of the workflows and steps on the platform. But if you don't know what data labeling means, then the whole process becomes very difficult. So those are concepts that we have to explain. I mean, we also have documentation for this, but at the moment, this is still a very manual process, mostly, where we go through the process of explaining those concepts.
Anyone else?
Thank you. I didn't understand very well what do you mean by deploying. Is your platform connected online to the data recording systems, or and if it's the case, how you deal with the heterogeneity of the systems that and the data connectivity issues?
Right. So we don't actually take care of the edge computing, let's say. This is something that is on our roadmap, but we are currently not doing. So all the computing happens in the cloud, and we connect through live data streams over MQTT or OPC or HTTP. So the way that the data flows is like user measures, sends to the cloud, and we receive, analyze, and send back in case something needs notification. And that also leaves, of course, the fact that we come quite late in the process in case the data pipelines are not in place. But we believe that companies should focus at what they're good at, and in our case, that's the machine learning part. And we have various partners who can take care of getting all your edge devices connected or getting your data pipelines up to spec.